Hey there, ladies and gentlemen, and welcome to lesson 12.2. On this lesson, we are talking about statistics and parameters. It's a pretty hefty lesson here, so stick with me. Do your best. Write down questions if you have them, and make sure that you are doing your best to understand so that we can understand the information to the best of our abilities. So here we're going to talk about the statistical inference. This is just the inference that we draw based off of the stats that we're collecting from the entire population. So we're just making some sort of a conclusion of some kind based off of our stats. A parameter is going to be the measure that describes a characteristic of the entire population based off of our stats, and then a statistic is just based off of the sample. Same exact thing as a parameter. Parameter is for population, and then statistic is for the sample. So this is for the population. That's an easy way to remember. Starts with P. Statistics starts with S, so it's for just the sample. So maybe that will be an easy way for you guys to remember some of those things. So here's a couple examples of that exact type of idea before we get into the heavy-duty math. So our job is to identify these four things. Here's our situation. A movie rental business selects a random sample of 50 orders in one day. Hey, so our sample is the 50 orders that are selected. And then, or movies. And then the population would be all of the potential movies. All of the orders that are happening from, or all rentals. The sample statistic will be the median number from the 50. So the median, and this is a number sign, not a hashtag, median number of rentals out of 50, out of our sample of 50. And the population parameter will be the exact same thing except for out of the entire all orders. So it's the median of all rentals. And that's how we do that, folks. This is just us using the vocab to make things make sense. So maybe you want to pause this one, see if you can do it before I do it so you know what's going on, and then see if what I say to you is the exact same thing you were thinking. So here it is, question B, a stratified random sample of 2 trees of each species. So that's my sample, 2 trees of each species. Then the population is going to be selected from all trees at the nursery. So that's my population, all trees. And then the mean height of the trees in the sample is calculated. So the sample statistic would be the mean of the 2 per species selected. So that's fairly easy. And then the population parameter would be the mean of all trees at the nursery. And that's going to be just using the vocab. Now here's the next stuff that gets a little bit harder. So check it out. I got a nice little step-by-step process for us and some things that we've never heard of before. So stay with me. So this is called the mean absolute deviation. The mean absolute deviation, the way we find this number is by finding the mean. Mean is this symbol right here, so X with a little bar over top of it. After we find the mean, we're going to find the sum of the absolute values of the differences between each value in the set of data and the mean. That means we're going to do this type of math. Okay? And we're going to just keep adding and adding and adding. Step 3 is to divide the sum of the numbers of the values in the set. So then we're going to divide by the number of numbers that we have. So here is our example. And you're going to want to have a calculator with you. So our first task was to find the mean of our data. This is my data that we're using. So we're going to take all those numbers. Remember that mean means to find the average. Average is to add up all the numbers and divide by the number of numbers. So in my calculator, I'm going to add up 14, 18, 12, 17, 15, 20 and divide by 1, 2, 3, 4, 5, 6 numbers. So 14 plus 18 plus 12 plus 17 plus 15 plus 20 is 96. And 96 divided by 6 is 16. So I found step number 1. My mean is 16. Step number 2 is to plug this number 16 into our formula for the most part. So this is going to be the sweet part of this. Absolute value of 16 minus 14 plus the absolute value of 16 minus 18 plus the absolute value of 16 minus 12 plus the absolute value of 16 minus 17 plus the absolute value of 16 minus 15 plus the absolute value of 16 minus 20. And that whole thing is going to end up being divided by n, which was 6. So that's a lot of math right there. It's not incredibly difficult math, but it is a lot of math. So I'm going to change it to my colors here. 16 minus 14 is 2. 16 minus 18 is a negative 2, but absolute value makes it a 2. This one's a 4. This one's a 1, and a 4. So I'm going to add up these numbers that I wrote above now and then divide by the number 6 to find my MAD, my mean absolute deviation. So in my calculator I got 2 plus 2 plus 4 plus 1 plus 1 gets me to the answer of 10 divided by 6. So my mean absolute deviation is going to be that 10 over 6, which is 1.6 repeating. And that tells me the average of how things are deviating from the average. Now, our next thing is also a fairly gross formula, but it's also kind of similar things here. So this one's called variation and standard deviation. So to find the variance of a number, we do steps 1 and 2. To find standard deviation, we follow through with step number 3. So similar type of a process. We first have to find the mean of our data. Then we're going to find the square of the difference between each value in the set and the mean. Then sum the squares and divide by the number of values in the set. That will give us a variance. This symbol right here means to find the variance. Now, after we find the variance, we can take that number and square root the variance to find the standard deviation. So standard deviation is shown with this symbol. So if you're looking for a variance, it's that symbol squared. Standard deviation is just that symbol. So this is the formula that we're going to use. So we take the mean minus the first number, square it, plus the mean minus the second number, square it, plus the mean minus the third number, square it, so on and so on and so on, and then divide by the number of numbers. The entire thing gets a square root stuff, and that's going to make this easy for us. All right, so y'all ready? Here it is. So what we're going to do is we're going to first find the mean. And the mean is, again, just us adding up all the numbers and then dividing by the number of numbers. Now, in my formula, this should go all the way down and cover up everything, not just the top part. So make sure you make that adjustment into your notes. All right, so we have 5 plus 7 plus 8 plus 14 plus 16. And that number is going to be divided by 5 to get us 1, 2, 3, 4, 5. Our mean value of 10. So now into our formula, we're going to find the variance. The variance is just this first thing without doing the square root of it. So we have in parentheses, we have 10 minus 5 squared plus a 10 minus 7 squared plus a 10 minus 8 squared plus a 10 minus 14 squared plus a 10 minus 16 squared. And that whole thing is going to be divided by the 5 numbers that we just did. So 10 minus 5 is 5. 5 squared is 25. So I have 25 plus. 10 minus 7 is 3. 3 squared is 9. 10 minus 8 is 2. 2 squared gets us a 4. 10, is this a minus a 14, is a negative 4. And negative 4 squared is going to be 16. And then 10 minus 6 is negative 6. Squared is a 36. So all this stuff being divided by 5. So in your calculator, again, you're going to do 25 plus 9 plus 4 plus 16 plus 36. That gets you to the number of 90, and then divided by 5 will get us our variance, and our variance is equal to 18. And to find our variance, now it's a weird looking symbol, that equals 18, that weird looking symbol squared. And then to find just the standard deviation, we're going to take the square root of 18. So we take the square root of 18, and that can simplify down to a nicer number, or if we just leave it as a gross looking decimal, we can get 3 root 2 or a 4.24. And that gives us how our data is spread out, and that's what standard deviation does. So the closer our numbers are together, the smaller the standard deviation, or how things vary. And the farther our numbers are apart, so if there's more spread from the biggest number and the smallest number, the farther apart the standard deviation is going to be. All right, folks, so this is what we're doing with standard deviation and the mean absolute deviation. If you have questions, feel free to ask. We'll talk about this stuff again tomorrow when you guys show back up for class. Make sure you take your notes, ask questions. This is the Bourbon Nation. We're signing off.